Okay, so the first problem, maybe I'll even have it up on the computer. Okay, so the first problem says that you have 1.2, nope, I put this wrong. Here we go. 1.2 pascals pressure, 245 Kelvin as a temperature. Notice there's no degree sign on there. 2.4 cubic meters. And what happens is the volume is reduced to 1.9 cubic meters, and then the pressure is changed to 1.7 pascals, which actually does make sense. Again, the pressure, if the meters were to go down, then the pressure is going to go up. So let's attack this problem. First of all, notice that you're not given n. So that means in order to make this work, you have to first, no matter what, you have to figure out what n equals in order to make the problem work. So you're given P, you're given V, R is a constant, we already know what that is. T you're given, so the only thing you're missing is n, so we have to solve for that. Here's how you do it, and again, we're going to use this for R, and you'll see how it works in just a second. 1.2 pascals, 2.4 cubic meters, that's for P, that's for V. N, we are not given, so I'm leaving it as N. 8.314472 cubic meter pascals per Kelvin mole. Leaving that there. If you want, I don't care, but you can leave it as 8.3144. Some people do that. Times 245 Kelvin. And now again, this is because we're not told what n is and we have to solve. All right, so 8.314472 times 245 eventually becomes, and notice Kelvin times Kelvin, the two Kelvins will cancel. So in your next unit, the Kelvin above here and the Kelvin below cancel. You do not include the Kelvin below. So this whole number, you multiply the numbers and you rewrite it without Kelvin because it cancels. 2036.93 cubic meter pascals over moles. And then this is 2.88 cubic meter pascals. We just multiply the numbers and combine the terms. N we have not solved for yet. We back up a little bit. We've got 2.8 cubic meter pascals equals the number of moles times this value. We solve for n by dividing both sides by this value, 2036.93 cubic meter pascals over per moles. Divide them both, and what do you think happens? If you take this value and you divide by this value, then the meters, cubic meters, pascals will cancel. Moles will flip to the top, leaving you a number with cubic meter pascals will cancel, leaving only just moles, which is what we're trying to figure out. So that's one of the reasons why we use this, because it really, for dimensional analysis, cancels everything quite nicely. So again, 2.88 cubic meter pascals divided by this number leaves you with 0.001413 moles, and that's your moles. That's what n is. Okay, so yay, we were given all this information and we figured out what n is. Now, when the pressure changes, when the volume changes, the number of moles, which is just the number of stuff present, that doesn't change. So it's actually a good thing that we were not told this in the beginning and we figured it out, because we know that number isn't going to change when these things change. So basically, we just rewrite the problem with a different P and a different V, but N doesn't change. And that happens no matter, and that's actually something, take a second and think about this for just 10, 15 seconds. If you change the temperature of something, you can change the pressure. If you change the volume, well, you can change the pressure, you can change the temperature, all those different things. But the one thing that doesn't actually change is the amount of stuff that's actually there. It's just either getting hotter, or it's having more pressure on it, or it has more volume to take up space, or less volume. But no matter what, N will not change once you know what it is. There's no amount of pressure or temperature changes that will change what the stuff is currently there. if that makes sense to you. The noise in the background is my kid having a great time, by the way. All right, so now that we know what n is, and n is 0.001413 moles, we plug it into the new equation where with the new pascals and the new cubic meters that were given. The new pascals are 1.7 instead of the 1.2. They're 1.9 instead of 2.4. And again, notice the volume went down, so the pressure went up. Okay? So you multiply these together to get 3.23 cubic meter pascals. We have the number of moles times the constant, and this time the temperature is missing. We were given the pressure, we're given the volume, we're given the number of moles, we're given our R, we're not told what the temperature is. So that's what we have to solve for. Okay? So it's multiply these two together, you get 3.23 cubic meter pascals. This number times that number, the moles on top, moles on bottom, the moles will cancel this time, leaving Kelvin only. Sorry, that's Paige in the background yelling my name. Once you multiply those together, you get 0.011748 cubic meter pascals per Kelvin. And then same thing here. We want to solve for T, so we take this number, divide by this kooky number here, and again, cubic meter pascals will cancel with cubic meter pascals. When you divide by this, it flips so that the Kelvin will end up on top. So take this number, divide it by this number, and everything cancels except for the Kelvin, which stays on top, and you get 274.94 Kelvin is equal to temperature. Due to, if you look at, again with dimensional analysis, you look at the sig figs, you want to cut it down to 3 numbers, so it's 275 Kelvin is equal to temperature.